So what we're going to do today is we're going to take a look at writing equations of lines given different sets of information. So before we get started, what I want you guys to do is take a look at this chart that is in your textbook on page 91, but I want to talk about a few key things. So just for the information that we'll be using today. The first point is slope-intercept form. Again, we know it has to be in this format, y equals mx plus b. Again, the m stands for slope, and the y-intercept, b, is the y-coordinate of our y-intercept, so where our graph crosses the y-axis. Point-slope form, that should have been discovered in the Khan Academy video last night. This is a different format, I know. Instead of using A and B, our textbook uses x1 and y1. All that stands for is the same exact point. So you can have any point, and that's going to be filled in the x1 and the y1 category. And again, m here is our slope. And when we're looking for the slope between 2 points, we know it's going to be y2 minus y1 over x2 minus x1 when we are given 2 points. Again, another way of saying that is the change in y over the change in x. All of those things are going to be useful for today when we take a look at different pieces of information. So our first piece of information, what we're going to look at is write an equation for a given line. So in this kind of problem, what we're always going to have is some line, and that is going to be in the form of a graph. So we're always going to have something that looks like this, and that's all you're going to be given. So what we have to do is we have to find the slope, and we have to find some point. In this case, we can find the y-intercept. So we know the y-intercept is where our graph crosses the y-axis, which would be this point right here, and we can identify that. We know our x-coordinate is going to be 0. We can't go anywhere right and left. To find the y-coordinate, we go down 2. That gives us the point -2. Now from here we have to identify the slope. So what I could say is I want to find the slope between 2 points. I'm looking for an easy point to identify, and I have one right here. This point would be the point 2, 1. So I'm going to look for my rise over run between these 2 points. I'm going up 3, so I know from there my rise is 3, and my run between the 2 points would be 2. So what that tells me is my slope is 3 over 2. I have my y-intercept. From there, I can actually go through and write the equation of that line using slope-intercept form. If I'm given a slope and a y-intercept, all I have to do is plug in for m and for b. Our m in this case we found was 3 over 2. X and our b in this case is the y-coordinate of our y-intercept. That would be -2. So we would have plus -2. Now from here what we could do is we could simplify this. When we don't want to have plus -2. Instead of saying that, what we'll go through and say is 3 over 2x minus 2. So this is the equation for the line that we had found over here. And if we check that in Desmos, we can actually see that that's going to be that exact line. Our y-intercept here is 0, -2, and we also have the point 2, 1 on that graph, and you can see up here that is the line that we had, that is the equation of the line that we had came up with. Now what we're going to take a look at, another kind of example. When we're given a slope and a point, now this is not going to be as easy to just plug into a formula. We can't just, or I should say, we can't just use slope-intercept form here. If we were, yeah, we could plug in for m. We know the slope. But what we don't know is b, because this is the y-coordinate of the y-intercept. 2, 3 is not our y-intercept. So we cannot just say this. Okay, we can't just say that, because that's not going to be true all of the time. Especially when this, actually never really when this is not the y-intercept. So what we're going to have to do instead is we're going to have to use point-slope form. Point-slope form, which we should have taken a look at last night in Khan Academy, looks like this. Y minus y1 equals m times x minus x1. Again, m stands for the slope, x1 is our x-coordinate of the point we were given, and y1 is the y-coordinate of that point. So what we'll do is plug all of that information in. Well, that -1/2 x minus 2. Now from here what we want to do is we want to go ahead and actually simplify this. We want to actually go ahead and simplify this. To do that, we could distribute that negative 1/2. We end up multiplying negative 1/2 and x, which gives us negative 1/2 x. Negative 1/2 times negative 2 is positive 1. Now we want to get the y by itself. To do that, we will move the 3. What we do to one side, we do to the other. Now y is by itself, and we are given this equation. Y equals negative 1/2 x plus 4. And when we take a look at Desmos, we'll see that this does have a slope of negative 1/2, and it indeed does pass through the line to negative 3, if we take a look at that. So here, what we were saying was we have a slope of negative 1/2. So what that means is we should have rise over run going down negative 1 to the right 2, which we could see here. That is true. I know it's kind of hard to see. You can't really draw on this. But this also passes through the point 2, 3. Here's our point 2, 3. And this indeed does have a slope of negative 1/2. And we can see this exact same line is the one that we had just came up with. So we know that all checks out for this one. Other example. Now what you can be given is 2 points. You can be given 2 points. And what the question will look like is write an equation for the line that passes through the points 1, 5 and 4, 2. So in the previous example, we had a slope and we just took a point and plugged it in. Now we don't have that. So what we have to do first is find that slope. And this ends up just being like what we had done in previous weeks. We use the slope formula. y2 minus y1 over x2 minus x1. So we're going to plug our information into that, and we're going to find out what the slope of the line between these 2 points is going to be. So we'll say 5 minus 2, I'm sorry, not 5 minus 2. We'll go 2 minus 5, because we'll call this point 2, and we'll call this point 1. So we would say y2 minus y1, x2 would be 4, x1 would be 1. So we go through, 2 minus 5 is negative 3 over 3. That simplifies to 1. So what that tells us is our slope is going to be negative 1. Now, from here, we could use point slope form. And we have a choice. We could use either the point 1, 5, or we could use the point 4, 2. And it really doesn't matter which one we use. And I'll show you that no matter which we pick, we're going to go through and get the same exact answer, as long as we're careful about plugging in and actually simplifying this. Our first step, we can use point slope form again, just like our last example. In this case, we're going to use the point 1, 5. So 5 is our y coordinate. Our slope, we said, was negative 1, which we found up here. And we would have x minus x1 in this case is 1. We're going to go through the same process. Simplify. Y minus 5 equals negative x. Negative 1 times negative 1 is positive 1. And then we would add 5 to both sides to get y by itself. So we have negative x plus 6. Now if you chose 4, 2, and we go through and we do this. Again, we are going to use point slope form. We have a slope and we have a point. It makes sense that it's named point slope form. That's the reason why. Minus 2, our slope again is negative 1, x minus x1 is 4. We go through and we simplify to get y by itself, like we had done in the last example. Negative 1 times negative 4, negative times a negative gives us a positive. Add 2 to each side, you get y by itself, negative x plus 6, which is the same exact answer that we had over here. And again, if we take a look at that in Desmos, oh sorry, I didn't realize that wasn't full screen. If we take a look at this in Desmos, no matter what, this goes through the points 4, 2. Here's our point 4, 2, and it also goes through the point 1, 5. 1, 5 is right here. So this line goes through those 2 points, so it ends up checking out in that case. Now our last example is we're going to look at parallel and perpendicular lines. I'll make sure I get this one full screen this time. What the question will say is write an equation to the line that passes through 3, 2 and is either perpendicular to some given line or parallel to that line. So for the most part, it'll be either one or the other that the question is going to ask you. So what we have to look at here is, one, we're given the point 32. Then we have to look at and understand what the relationship is between perpendicular and parallel lines. When we look at perpendicular lines, the slopes have to be negative reciprocals of one another. Our slope here is -3, so that means in a line perpendicular to that, it needs to be the negative reciprocal of -3, which in this case would be 1/3. Okay? And now we go through and we use that point 32 and our slope of 1/3, and we use point slope form. So x minus x1, we plug all of that information in. Y minus 2, then our slope is 1/3, x minus x1 is 3, and just like before, we go through and simplify this. 1/3 x, 1/3 times 3, be -1, add 2 to both sides. You get over here y equals 1/3 x plus 1. So now if we take a look at this in Desmos, these two lines should be perpendicular to one another. Here's our line -3x plus 2, which was our original, and we should have 1/3 x plus 1. So yes, they meet and they create 90-degree angles, which makes these lines perpendicular, and this has to pass through the point 32, which in the orange it does. All right, and the 3-2 right there. Okay, so those two lines would be perpendicular, and it is going through the point 3-2. So that one ends up checking out. Now let's take a look at parallel. For lines to be parallel, we know that their slopes must be exactly the same. So in this case, our slope is going to have to be -3. We can identify that just from looking at this because it's in slope-intercept form. Slope-intercept. Now we go through and we plug all this information back in again into our point slope form. Y minus y1 is 2. Our slope now is -3. Our x still stays the same, and x1 is now 3. So we go through, simplify this. Y minus 2 equals -3x plus 9. Add 2 to each side. What you end up with is -3x plus 11. So let's double check this one. These two lines should be parallel, and I recommend doing this for a lot of these. If you're not sure about things, double check in Desmos. So if I take a look at these two lines are definitely parallel. They never are going to intersect. And this black line should run through the point 3-2, and it does. We see that here. Now this is a great website for you to use, so I definitely recommend it any opportunity that you get just to plug things in and check it on your Chromebook. So we see that all of these things check out.